Welcome to Decision Arts, transforming data science into an art.
Welcome. In this video, we would like to give you a glimpse of what you can expect from Decision Arts in the upcoming videos. Well, if you have watched the data in data science video, you would have seen the following graph. This graph clearly shows you how we can look at data from two different dimensions. One is types, or in other words, forms, and two is the various domains. Taking pointers from that video, there is going to be playlists which explains each and every type of data in detail. For example, in the time series playlist, you can expect to find what is time series and what are the general formats we get to find time series data, how to analyze time series data, and how to model and forecast a time series data. Similarly, you can find playlists on tabulated data analysis and modeling, NLP, computer vision, audio decoding and analysis, video tagging, and other generative algorithms on images. Now, traveling up the domain axis, we will deal with various common or known problems in each of these domains and what algorithms are at play to rescue the industry from these problems. It is also important to note that some domains have a very high affinity to a particular form of data. For example, social media is highly about text, images, and video. Rarely we find tabulated data. On the contrary, in the retail domain, most of the data is tabulated and structured, and we find very little use for video data. But hey, if we can marry these untapped areas of types and domains, who knows, we could uncover new possibilities in data science. Lastly, we would also throw some light on how to handle unstructured data and how to architect an entire data science solution. Mainly, when to choose cloud, when to choose big data systems, when to rely on available servers, etc. And we'll also solve every other data engineering problems that we come across. It is also really important to note that when we talk about data science solutions to problems, there is an inherent problem solving method. First, we ask ourselves, can I identify features, do feature engineering, and solve this statistically? And number two, in case if we have too much of data with good quality, can I ask the machine to understand the data better? Number three, now that I have understood the data by machine learning models, how to create architectures around this core model to start catering to various business problems. Number 4. I have too much data and resources that can help supervise tagging. Should I step up to deep learning? The last step is, should I engineer a deep learning architecture or shall I reap the benefits of attention and get my solution from one of the best state-of-the-art transformer model? Well, that's the flow. Sounds interesting? Get ready to revel in the most happening field of this decade and subscribe to catch all this and more at Decision Arts, transforming data science into an art.